Hello my dear students. Today I'm going to teach you chemistry of alkenes, and I will not only introduce alkenes, you will also learn how they are named and what are their physical properties, including discussion of changing trends of melting and boiling points and their physical states and their solubilities, and we will also learn in detail about the chemical reactions of alkenes. So here I begin with the name of God. Just watch the lesson very carefully. First I introduce you alkenes. Alkenes are the hydrocarbons that contain a carbon-carbon double bond in them. So, to be an alkene, there is a condition that the structure must possess a carbon-carbon double bond. You know how this double bond is formed? This is a multiple bond. And out of these two bonds, one is a sigma covalent bond and the second one is a weaker pi bond. So the multiple bonds means it is unsaturated center. You studied about alkanes that they are saturated because they are singly bonded. But today you are going to learn about a doubly bonded carbon. And this doubly bonded carbon is called as unsaturated because of having this double bond. The next is this carbon-carbon double bond is very important because it becomes the reason for all of its chemical properties, and that is why it is responsible for all the chemical reactions, and this is due to the functional group of alkenes. So as alkenes are named and are identified and they react just due to this double bond, that is why we say the functional group of alkene is its double bond. If a hydrocarbon has a double bond, then they all will be following a general formula CnH2n, where n represents a whole number, means how many number of carbon atoms are present in the molecule, and the smallest number is 2 because to make a double bond we need at least 2 carbon atoms. So now alkenes are defined or introduced in detail. Today we just proceed ahead to know how they are named. I repeat that here I'm just comparing the naming pattern of alkane with the naming pattern of alkene, and we are going to cover the IUPAC names. Okay, the systematic names. You remember that the suffix or the ending part of the name assigned to represent saturated compounds or alkanes was ANE. And you can see that all of the alkanes are ending at ANE. So this is what? This is their naming rule. Similarly, the alkenes are assigned to write their names with a common suffix that is ENE. And you can see that all of the alkenes are ending their name at ENE. Now I repeat one more thing, that as the prefix used to name alkanes was eth, prop, bute, pent, hex and so on the basis of carbon numbers present in the compound, and the same prefixes will be used in alkenes: eth, prop, bute, pent and so on. So only one thing is different: alkanes having molecular general formula CnH2n plus 2, that is why they were alkanes. But here you see the hydrogen atoms are just 2 times of carbon. You see 3 2 times 6, 4 2 times 8. So the general formula is CnH2n. So a different class of compounds having a double bonds in them, a different suffix is assigned to them. Now we cover the whole naming pattern again. Now you see, when the alkene is a normal alkene having no branch on it, then we will see like this CH3, CH2, CH, double bond CH2. We will see how many carbon atoms are present in the chain. So there are only 4 carbons. Now we see how many carbons are there? Just 4 carbons. And we have to locate the position of this double bond. So we will start counting the chain right from the corner where the double bond is nearest, because this is the functional group. So here I have 1, 2, 3, 4. So my parent is BUTENE. But because 4 carbons are making up the compound, and this ENE means the double bond present in the compound. That's for alkene. So to locate the position of this double bond, that's between carbon number 1 and 2, we are assigned to use the smallest position, and that is 1. So we write here 1, and we connect always a digit with a word with the use of a hyphen. So the name goes 1-butene. Now you see, again we have 4 carbon chain. So the name will be but ending ENE. And here you see the double bond is equally distanced from both of the corners. So I started counting from this side. You can start from this side as well. So all the time I'm getting carbon number 2 and carbon number 3 with a double bond. So the smaller number is 2. So I write 2-butene. This is the case when we have no branch of alkyl group on the parent chain alkene. But in case if I have the branch, then point number 3 will be working here. We will be naming the branches also. Now you see, in this example I have put a methyl branch on the chain. Now again a 4 carbon chain with a double bond. I start counting from this side. 1, 2, 3, 4. So the name is 1-butene. But in this case, you see the parent is again 4 carbons having a double bond. But you see, you have not named this group, which is considered as a branch of methyl, because only 1 carbon is there. So there is a branch of methyl attached on carbon number 2. So we are going to name it just before the parent. So this is the place to write about the position of any branch. And what is the branch? That's of methyl. And where it is located? It is located on carbon number 2. So it goes like this. I told you, always if 2 numbers are there, you can link up them using a comma, and to link up a number or a digit with a word, always use hyphen. So the name goes 2-methyl -1-butene, or this is 2-methyl butene. So this is what you see all the time. Whenever such structures come to be named, you will be following these 4 rules. Now we come ahead to discuss the physical properties of alkenes. The first 3 alkenes, including ethene, C2H4, propene, C3H6, butene, C4H8. Why I'm telling the formulas very easily? Because I remember that how many N's are carbon, hydrogen will be exactly 2 times of carbons. So if carbon is 2, hydrogen is 4. If carbon is 3, hydrogen is 6. If carbon is 4, hydrogen is 8. And these are all gases at room temperature. So these are the gases. So you will be writing G with them. The next, the melting and boiling points increase as the molecular mass increase across the series. So just have a look on this table to understand how and why the properties, the melting points and the boiling points and their physical states and density is changing across the series. The first one is the lowest one with the minimum molar mass, and as you go down the series, the carbon atoms are adding and it results in the increase of molar mass or molecular mass. So you see the first three are gases because they are lighter in mass, and the following alkenes are liquid. The increase of molar mass also results in the increase of their densities. This is not the whole story. The melting points and boiling points are also increasing down the group or across the series. Why? Because of the increase of the molar mass. The carbon are adding in the molecules, and molecules are getting bulkier. As they are getting bulkier and heavier, which results in very strong network of forces which can bind them. I'm talking about the van der Waals forces. So when so many forces, van der Waals forces, are working among the molecules, we need more heat to overcome those forces. So that's why a compound is melted and is boiled at higher degrees. Now we come to discuss the chemical reactions. Physical properties are all about the properties which can be judged, which can be observed using senses. But the chemical reactions means the chemical properties. When some change happens, when a reaction is taken place, and when something new is produced. So the first reaction of alkenes, which will be discussed in this lesson, is combustion. So alkenes burn in excess of oxygen which is present in air to form carbon dioxide and water vapor. And we can write the general reaction by writing the formula of alkene, then oxygen producing carbon dioxide and water vapor. Suppose alkene is ethene, that is C2H4, is reacting with oxygen gases to give carbon dioxide and water vapor. Okay, and to balance this reaction, I'll be putting 3 over here, 2, and 2 will be here. Yes. So I have given you the balanced chemical equation. You just practice writing similarly. And there's one more thing which should be observed, that when we perform this reaction, we find a sootier flame. Sootier flame means more carbon particles are releasing in the air. You see why this happens? Since alkenes having a large percentage, or relatively larger, higher percentage of carbon than corresponding alkanes, the carbon particles or the black particles are producing in the air. So alkenes burn with a sootier flame as compared to their corresponding alkanes. Now next reaction is very important, and that's addition reaction. To understand addition reaction, first I will explain you what addition reactions are and how they happen. So you see there is a compound having this double bond in them, and in the beginning I told you one is a sigma bond, which is a stronger bond, and the next bond is always a pi, which is a weaker bond. Okay, so what happens, these two molecules, there is a molecule which is reacting with this doubly bonded carbon and producing something 1. Two molecules are making one molecule. So in chemistry we say that a molecule is added to give a larger molecule, And how it is happening, the X and Y, suppose two atoms are adding to these doubly bonded carbons, one of the pi bond breaks up and two new sigma bonds are formed. So how it is happening? The doubly bonded carbon atoms like this reacting with X and Y, the pi bond breaks up and both of the carbon atoms, two bonds were already there, and the new sigma bond or the covalent bond is formed. One is with X, the next is with Y, and we say that there is addition reaction going on, and always addition reaction takes place at unsaturated compounds. Now it's not very simple. Today you will learn about 4 common addition reactions which are taking place at alkenes: hydration, hydrogenation, bromination, and addition polymerization. We will discuss them one by one to make it easy for you. Now when we talk about hydrogen, hydrogen is a molecule, and it's a diatomic molecule coming to react with alkene. So alkene is a center where double bond is present, right? And hydrogen means two atoms of hydrogen are bonded, and when this bond will break up, both of the hydrogen atoms will make a bond with these two doubly bonded carbon atoms, and the conditions at which hydrogenation is carried out, it's very high temperature, means 200 degrees Celsius, and the catalyst to speed up this reaction is Rene nickel. It's an element, transition metal hai ye. Acha, how it happens? Again, the double bond is broken down and a saturated compound is formed here. You see, from ethene, which has a double bond, we are getting ethane, which has no double bond in it. The compound is completely saturated, having all single bonds. So this is what the hydrogenation results in, the saturation of organic compounds. Now you have to learn one thing, that the remaining constituent atoms are exactly written in the product. The carbon content remains the same. Suppose the alkene, if it has 3 carbons in it, 1, 2, 3, only the reaction involves is this saturation of this double bond. So you have again 1, 2, 3 carbons in the products. Again, conditions are same, 200 degrees Celsius in the presence of nickel. I am explaining you this reaction in detail because this is a very important industrial operation which is used in the making up of margarine. How? We take oil which has so many carbon-carbon double bonds, naturally, vegetable oils, and we add hydrogen into these double bonds to make them saturated like this. Same reaction. The saturation means the double bond is added with hydrogen to give saturated compounds, and the product is the very yummy margarine. So margarine is produced from oil by simply adding hydrogen into it, and the conditions are maintained. Next is bromination. Bromination is also a very useful reaction because this test is used for distinction of unsaturation and saturation. Like if we are asked to detect or identify the presence of unsaturation, double bond, so we perform this reaction. And how we perform it? We take bromine water. And what is bromine water? Bromine is a brown color liquid. So when it comes to react, the reaction is performed and the brown color is vanished or disappears. How it happens? You see, before reacting, the bromine was brown in color. When we add a compound which has a double bond in it, bromine is added to give us a saturated dibromo compound. and as the bromine is vanished, is consumed, the brown color disappear. So the color change from brown to colorless is the confirmation of the presence of a double bond. So we perform this reaction and we call this reaction as identification or distinction test for carbon-carbon double bonds or carbon-carbon triple bonds. So this test is performed with a color change. The next is addition of steam. Now what is a steam? A steam is again water vapor. So the term is related. That comes from hydra, which means water. So in this reaction, a molecule of water, that's H and OH, the bond breaks. One of the carbon gets hydrogen and the other carbon gets this OH, and we have a very useful compound in the product, that's ethanol. Why this is ethanol? Because of having this OH group. This is the functional group of ethanol, and this time the compound is not only saturated, we are getting a new functional group introduced to a hydrocarbon. And the conditions at which this reaction is performed is again a very high temperature, that is 300 degrees Celsius, and the pressure maintained is 60-80 m in the presence of H3PO4, that is phosphoric acid. The next and very important reaction is polymerization. To explain polymerization, the equation is very easy to learn it, but let me explain you the whole story of polymerization. Polymerization can be understood by this picture, that these are the students standing at distance and they have no link in between and they are individual, but when they join their hands, they make up a line, they make up a longer line, so they make something larger. And when they were unattached, they were called as monomers. So monomers are the small molecules which link together to form a larger compound that is called as a polymer. Okay, so alkenes break their double bonds to undergo addition reactions, and in this reaction the monomers, the smaller alkene molecules, join together, add together to make a larger molecule, rather polymer. And the polymers typically contain thousands of monomers and many useful plastics, and this is making in fact the polymer. So all the kinds of plastics and other polymers are the addition of alkenes. Now how we performed it, we see the smaller alkene is added to give something very large. And how many molecules are there if we represent it by N? So all the molecules will be linked up. And why this is going on? Just because of this double bond. So alkenes open up their double bonds and they start joining with the other fragments like this. Okay, so alkenes are added. So why this reaction is called as addition? Because the double bond is taking part in it, and this is again performed at a very high temperature. It's performed at very high temperature and pressure in the presence of catalyst, and this reaction is called as addition polymerization. And the starting monomer, the smaller molecules are ethene, and the bigger one is called as polyethenes, and this poly means many. So they're many alkenes or ethenes joined together. Have you heard of this name, polyethene? Yes, I'm talking about the shopping bags normally we use to carry our things. Okay, class, I'm leaving you with the hope that whatever I explained you is very important for you. You just watch the video carefully and you go through the textbook to understand, to get full command on this topic. And next lecture will be all about the topic cracking and producing more useful compounds from petroleum. Just to finish this chapter, till then, take care. God bless you. Khuda Hafiz.